Group 7, and our group consists of Will, Joe, Nick, John, and myself. And the concept that we're proposing here is a power generation Tesla race. Our product is a fully engaging head-to-head race to build electricity. After a brief informational overview of turbines, 2 volunteers will pull from the audience and pit it against each other. They'll have to spin their wheel, imitating the magnet spinning within copper coils, as fast as possible to generate electricity faster than their opponent. As they begin generation, various LEDs will light up, heading towards the top, indicating the energy has been created. When one person generates enough electricity to reach the top, their objective up top will come alive with electricity, putting on a show for all to see using a Tesla coil. And obviously our product will be hitting the hidden tower exhibit that they're going to have at the Franklin Institute. So this is our product here. As you can see, it has 2 mechanical cranks in the front. They're going to be used by both the operators. And 2 meters up top, on top of those cranks, are going to be lighting up. And once they hit the top, 2 Tesla coils up top will emit an arc showing that one team has won. And the dimensions of our product are going to be a 12 by 6 by 4 base with a total height of 12 inches, also 1 foot.
Our primary concern was that the interactive would be eye-catching and able to hold our users' attention. By displaying an electrical discharge on the top of the interactive, users will be intrigued from across the room, and then the competition will keep the users engaged until the cycle is completed. Our next concern was that the device would be capable of multiple cycles and operate the same way every time. Our last need that absolutely must be reached is that the users are taught something about natural and applied sciences. The natural science taught is magnetism in relation to induction. Induction is the method of power generation within our device. The device casing will be transparent so that the user can visually see the magnet spinning. When the magnet is moved relative to the conductor, an electromotive force is created. The wire will be connected to a complete circuit that will allow current to flow. This details the transformation of kinetic energy from turning the wheel to electrical energy. The applied science taught is power generation, which is shown by the LED lights illuminating on the face of our interactive. Also, a Tesla coil will discharge on top of the interactive to show that the power generation has been completed. We have here a short video of how induction works. On the left is a magnet, and on the right is our coil. And as the magnet moves through the coil, you can see the voltmeter on the bottom right going up and down with the motion. As the magnet goes through, the magnetic field passes through, and it creates induction, which creates our electrical energy.
Another concern of ours is manufacturability. We want most of our components to be available on MasterCard, Amazon, or your run-of-the-mill hardware stores such as Lowe's. We want to use a transparent base, so acrylic would be necessary for that. Because it's low cost, easily purchased. Copper wire can also be easily purchased at Lowe's and all the other sources we have listed. We need minimal tooling to produce this. The machine shop would be necessary for cutting the acrylic to size, but other than that, there's not much beyond hand tools. The most expensive components would be the Tesla coils, but there are ways to produce those using an incandescent light bulb. Our product is unique. We weren't able to find anything else on the market similar. Power generation is not usually shown in a competing sense. But this format makes it easy to understand how power generation can happen faster through more kinetic energy, while additionally applying the competition aspect. Although the Tesla coils can be bottom line, they're normally used for entertainment purposes instead of demonstration purpose such as ours. There are no records of this pairing available commercially. Some of the technology we wanted to explore with this was we wanted to explore the use of the microcontroller to control the LEDs in the overall competition, such as the discharge of the Tesla coils and the measurement of the input. An Arduino or similar device we figured would be used as a controller. Another big thing we'd have to look look at is analog data to digital input, i.e. the cranks are going to be analog data, the volts, transferring to the Arduino to transfer to the LEDs, and ultimately the Tesla discharge. The last technology we have to explore is hand crank power generation. And for those who are unaware, here's an animation of the Tesla coil to kind of give a rough idea of what the discharge could look like. Thank you for your time and attention. Are there any questions?